I think I was at the roots of the Russian scene, which combined electronics with metal, which was not very
Ooh.
popular at that time. Right now, everyone's doing it, but
Anyways, I
back
don't know
then,
if you guys
Fascinating.
read the word or just like focused on the music, but I think the words and the music were equally important.
Fascinating.
okay. So now, yeah, I I
Um,
wasn't able to read all the words because when you translate video, it sort of does the frame jump a bit. So
Yeah.
maybe if you can share the video then so that we can watch it separately. I wasn't able to read everything. So
oh, you
I
weren't.
noticed
No.
I noticed a lot of familiar names and praise
Okay.
for
So,
people.
well,
And
But if you
it's not
think doing it,
maximized. If you can
yeah,
maximize the screen.
we'll just sing.
well, you can read it now, right?
Well, not at
Yeah.
that speed, but
Slow
Well,
it down.
um,
I think I got most of them.
well, it will scroll again. So,
all right. I say let's start. Maybe.
yeah, you can start. Well, I'll I don't know how to mute the sound. Okay.
So a bit of old-fashioned disco.
Wait, how do I stop hearing this?
We have no idea.
It's totally a chaos, man.
Okay, but I think I managed to read most of the
Well, for those who
praises.
couldn't read the whole thing, I think it is recording, so you could look at it on YouTube later.
Okay.
Um,
I
million.
think you should just put it separately on YouTube.
I mean,
It's worth it for the music.
I know. I
Yeah.
mean, you could go back to.
Right. All right. Well, that was very nice. I read at the end the thanks to your husband. So
Yeah.
who allowed you to do one more year of this and sort of went with.
Well, I
Um,
mean, the price was very, very high.
oh, I can imagine. I can
Um,
imagine. I'm in a
because
similar situation.
um, he basically, made me write all of our daughter's school application essays. That was what I
Oh,
had to promise in
okay.
exchange, and I hate writing essays.
I can imagine. Okay, so shall we? Shall we? I see, I know Dieter is here. I don't think Emma will be able to join us today because, like we were joking, she has a real job. So, unlike us. Let's start. Today is our 17th session, week 17 of Life After Code in Place 2025. And with a heavy heart, like this is the last week and this is the last session, and Vicky is going like, woohoo, finally. But
Well,
yes,
same for
today
you
is,
too, I'm sure.
it's a two-edged sword. On the one hand, we're finally coming to the end, but on the other hand, it's always a bit sad to end these things. But anyway, week 17, and I actually, because Vicky sent me as always, a Calvin and Hobbes strip, but I took another one. I think you posted that one on somewhere. I,
Yes, ours,
I, I
ours, ours,
remember I saw it somewhere, so I'm actually going to place it here because it's Halloween. So it had to be something about Halloween, but I changed it a bit. I took some, artistic liberty in this one. So Kevin is asking, what are you going to dress up for as Halloween? And Hobbes says, I don't know, I can decide yet. And he says, well, the idea is to be the scariest thing you can think of. And Hobbes said, well, maybe I'll just go as myself. And to turn this into a programmer's joke, Kelvin says, I'm going as C++. So that's the scariest thing I
Um,
could think of.
Alex, I also sent you another deck. Did you not get that?
That depends on what you mean by another deck, but if you're talking about Halloween photos,
Yeah.
so here they are. We
Okay.
have some happy Halloween photos. I don't know most of the folks that are listed here. Of course,
Oh,
I
you
know Mark
don't know these
Zuckerberg
people?
and Priscilla, so that's the only one I do know. So you'll have to comment. And
Okay.
I don't understand what's so happy Halloweenish about this one. It
Well,
doesn't have.
I mean, they didn't really decorate their house. Okay.
Ah, okay. They don't
Um,
care for Halloween.
their their house is at 1456 Edgewood, Palo Alto. Um, they bought like several lots, and so it's very, very private. If you're ever in Palo Alto, that's their address.
So yeah, no pumpkins there. But then there is this one with the ugly pumpkin.
Okay, this is I forget the number, but it's on Addison. This is Marissa Mayer and Zachary Bogue's house. Marissa Mayer, I think, used to be the CEO of Yahoo. I don't know what she's doing now, but probably CEO somewhere. And
Okay,
so their house is known for having big, huge, like huge, literally huge, ugly pumpkins every year.
so that's their specialty. Huge ugly pumpkins. Okay, so
Next.
here's the next one.
Okay. This is Larry Page and Lucinda Southworth's house. Larry Page, hopefully you know who Larry Page is, Google. They
Yeah.
live on Waverly Oaks, kind of like a street kitty corner to Steve Jobs' house.
Okay, and we go to the next one because
Okay.
there we go.
This is like the famous one. It's been here like 20, 30 years every year. This is Steve Jobs' his house. I think Peter knows, I forgot his address, but he lives on Waverly. So every Halloween, they put on a big show. It's different every year. People start lining up at about 4 o'clock. Door opens at 5 or 6, and then they give out candy for 2 hours and then shuts down. And then all of the streets around it for like half a mile is like blocked because there's just like so many people. Okay. Obviously Steve Jobs is no longer with us, so this is Lorraine Howell Jobs' house.
Okay, and this is the old photo of Miran because I think I saw you somewhere send me a newer one and I lost it. I have no idea where it is.
I think it's on your WhatsApp, but
Oh, could
this
be.
was Aaron's house from last year. As you can
And
see,
that's Maran in the window.
yeah, this. Um, so address withheld. Um, but yeah, this is Aaron's house. As you can see, there's like lightsaber shows. This year the decoration is a little different. He has like graveyard skeletons in front. So
Okay, so happy Halloween, everyone. Regardless of whether you dress up and go door to door asking for candy, which could sometimes be dangerous, still happy Halloween. So let's try getting back into, you know, our regular session mood. I think this has been enough for 3 seconds, so let's go. For office hours, Dieter will still hold office hours next week, although I'll have to check with you again. So you will be here on Wednesday, but I don't remember about Thursday.
it's
Will
all
you?
Dieter's show. Dieter will do both.
Okay,
Yes,
Dieter will
Emma
do
couldn't make
both.
Thursday, so I'll stand in.
Okay, thank you very much, Dieter. So yeah, this is going to be the last week. So next week is the last week of official office hours for Life After Code in Place. And the plan for today, we are first going to talk about the Gladiator assignment, which was for solution for it because it uses materials from the previous session. Then we're going to talk about several topics. Vicky asked me to talk about decorators, so I will talk about them. They are not
Yippee!
they're OOP specific, but they are used in OOP, so we'll tackle that. And then specifically for OOP, we'll discuss getters, setters, and properties. And as I know, these things have also been discussed by Nick in the video recorded, so thank you, Nick, for that. I didn't look through the inheritance one, but I looked through decorators and getter setters properties, so those were very cool. And the remaining time we'll use for a more extended OOP example. Just look at, it's still going to be rather simple just because we don't have that much time, but we'll try to craft something approaching real life use of OOP. So let's go first with the Gladiator assignment. So here's a quick reminder of what that assignment was about. Basically, it's a very simple simulation where you have two gladiators that fight each other, and we already have the main.py file, so we have the main function, but we need to create the gladiator class. So that class represents a gladiator. So we will have two objects of that class, two gladiators that hit one another in order until one of them goes down. So we need to create three methods. We need to create the initializer, which is responsible for the initial construction of the object. We need to create the strdunder method, which is responsible for printing out the stringified version of gladiator objects. And the main method that we need is the perform attack method, which actually takes in two parameters. Well, by default, it takes the self parameter, which is the gladiator itself, the attacking gladiator, but another gladiator is passed in as a parameter as well, so that will be called other, and there are virtual dice roll to see how many hits one lands, how many the other one defends from. The difference is subtracted from the lives of the attacked gladiator, and we need to print out the relevant message. So either the gladiator is hit and he loses a certain number of lives, or the gladiator misses. This has been described in more detail in the PDF file that we provided for the assignment, so I'm not going to go into all the details. So now I propose we go into VS Code and actually together go through it. So give me a second. I will open my VS Code. Do you see my VS Code now?
Yes.
Okay, so let's quickly go through the main function that's going to run this program. Basically, first we're going to create two objects. One is going to be called current player, the other one is going to be other player. And we will use a separate function which is called getStats, which will take four statistics for each gladiator: a name, number of lives, the attack value, and the defense value. And then we will randomly decide which one is the first one, which one is the second one. So basically, the first one is the current one, but with a 50% chance, we will switch them places. So the current one will become the other one. And then we have a condition. The condition is while the current player has at least one life, so he's still alive, we will call this method, the perform attack method, on the other gladiator. We will print out the statistics of the other gladiator, so to see how many lives he has remaining. Then we will once again switch them places, so the other player hits back, and basically that's it. And we do this over and over and over again until the current player has 0 lives. The loop ends, and we say which gladiator is the winner. So that's basically the logic of the game. So now we have to write the gladiator class itself, specifically 3 functions. There is also a helper function here which rolls a number of dice. So we tell the function how many 6-sided dice we need to roll, and it returns the number of 6s which are rolled on these dice, which is a success. So let's go from top to bottom. So basically we have the initializer, which receives the name, the number of lives, the attack value, and the defense value. So this is all described here. So what kind of code do we need to write here in the initializer?
Self.name, self.live, self.attack, self.defense.
Yeah, so nothing fancy here. We do self.name equals name, self.lives equals lives. So we actually initialize the specific object we are creating with the values which are passed as parameters into the initializer. So this part is simple.
Alex,
We could have done something, yes.
are those attributes? I'm still trying to like.
These self-name, self-life, self-attack, self-defense, these are 4 attributes
Okay.
of the gladiator
And
class.
are they the synonyms to like instances?
No, an instance in
Oh,
the object is
an
an
object.
instant.
All
These
right,
are
okay.
instant variables. That's what you're thinking about.
I still get
Attributes
them very confused.
okay. So an instance is an object, so that's why you call them instance variables. So now let's go to the str_dunder method. We need to provide a string which is a description of the gladiator. So the main thing we're interested in is the name and the amount of lives the gladiator has, but also we can provide a shorthand for the attack and defense so that we see all the stats. So what do we write here?
Just like return, and then you can use like an F string in that whatever curly bracket parentheses self.name. And then
We could say something like gladiator self.name.
yeah. And then you do the same for like lives, attacks, defense.
So we would say has
Yeah. Whatever you want.
self.lives. Lives, and here I think in parentheses I had like attack and defense, or attack self.attack, defense self.defense. Okay, the only question here is how do we change this if instead of several lives we have the number 1 here? Like 1 lives does not sound good. How do we change this so that if it's 1 life, we actually return 1 life and not 1 lives?
Can you have an if statement?
I could have an if and else statement, that's true, but we could do this simpler, keeping it a 1-line statement.
I mean, I guess I guess that I don't.
We can use a ternary operator, which has an if
Yes.
and an else.
Yes, I would propose doing a ternary operator. Mansi agrees with you. So we would have lie in any case, and then we can do like if self lives equals 1, else this. And so here it would insert either this one or that one, depending on the number of lives that we have. In this sense, English is simple. Only with 1, you have FE. In all other cases, you have VES. If I were to do this in Russian, I would have a longer string here, because we have different endings for numerals 2, 3, and 4, and then everything which is 5 and above, including 11, 12, etc. But then at 21, you still have the different endings, so it's not as easy. Okay, so let us now discuss perform attack, which is sort of the most interesting part here. So
Sorry,
basically,
Alex, can I ask you a question? Why is
Yeah.
the string method a dunder method again? I forget.
because this is it's a built-in method. So every class has this method, and if you want to override it, you have to write it like this. So basically, all Dunder methods are methods that are included by default. So that's what Dunder methods are. And this is what happens if you print the object. It will automatically use this method. So now let's perform an attack. So the way this works, so once again, we have two parameters. The self parameter is there, and the other will also be a gladiator object. So we need to roll the attack dice and see how many hits will end. The hit is a 6. Then the other gladiator rolls defense dice. Every 6 is also a success. We subtract defensive successes from the attacking successes, and if the difference is positive, that's the number of injuries which are inflicted on the gladiator. That's the number of lives he loses. Otherwise, there is no damage. 0 or less hits. In this case, there is just a message that the attack misses. So how do we do this? Any thoughts how to approach this?
I'm not sure the syntax because I'm super behind, but I think conceptually we want to we want to figure out how to roll the dice for self-attack and self-defense and then subtract them to see how many hits we got. But I'm not sure the syntax because I've been traveling, so.
Okay, so basically we have already a function pre-written for us which rolls any number of dice and returns the number of 6s that you get. So we don't have to write this function. We already have it.
So do you write like self.attack equals?
Self.attack is the value.
Oh,
so
okay. So you have to do lives. Or sorry, attack.
For instance, you could say like attack.
And then call the function roll _ d6.
Mm-hmm. What would the parameter be?
And is 6 or how are we deciding what?
That's the attack value. The higher your attack value, the more dice you roll. So that's the number of dice you roll.
So we're rolling a 6-sided dice, so it's just N6? No.
If for instance your attack value is 10, that means you roll 10 dice. If your attack value is 1, you roll 1 die, and so on and so forth.
You can think of the attack value as his strength, and if he's stronger, he gets more dice to roll, so a higher chance of getting 6s.
Yeah. So I see Nancy saying in the chat, so here we need to use self-attack because that's the value that determines the number of dice you use in an attack. And we will get a result. So how many successful attacks we have. Let's say call it attack successes. So what's the next thing we need to do?
Same thing, but with defense.
Okay, but it's not the same thing. That's the difference. So what do we write here?
Would it be roll d6 but with self dot defense?
But he's not attacking himself.
Other dot defense.
Yes, we need to take the other gladiator and roll his defense. So basically one gladiator is attacking, the other is defending, and then they compare the results that they got.
Got it.
So what's next?
You want to compare like how many 6s?
So like hits?
Okay, hits, good.
Equals attack successes minus defense successes.
Exactly, that's good. Okay, we have the amount of hits. So what's next?
If hits are greater than 0, let's see, it's self,
and then the
other
lives.
dot lives minus
Um,
1, or I don't know how many
well,
hits.
it would be
Track the amount
minus,
of hits.
it would be subtract the number of hits.
Yeah, so you could write minus equal hits, and that's the amount that will be taken from the other player's lives.
Right, and then you want to check if other lives is less than 0 after you do the
Yeah,
subtraction.
yeah. So you go
If it's
now
less than
other
0,
lives.
and they're gone.
The question is not that they're gone because we're checking this in the main function. The thing is that you cannot have negative lives. So in case you have them less than 0, you have to set them to 0.
Oh, okay.
And in this case, we need to print a message which says something along the lines of
Like attack successful.
like gladiator hit gladiator this for I don't know, for this points of damage. So help me out with filling out the brackets.
That's self.name.
Yeah, so the first one dot name.
And then the second one would be other dot name.
Other dot name, exactly.
And then the third one would be hits.
And so here as well, if we want to be good about it, we should say that it's an empty string if hits equals 1, else s, so that we have 1 hit or 1 point of damage, but 2 or more or 0. Well, we won't get 0, like 2 or more points of damage, so we get plural. Otherwise, if the number of hits is 0 or less, what do we do in this case?
Attack failed.
Yeah, we're gonna say that gladiator whatever missed. And this one is going to be self-name, and we're do it as an F string. So
is your baby okay?
I don't hear him because you hear him. I have noise canceling earphones. I have people taking care of him. So yeah, let's try this one. Let me save this and let's see. I will probably add the print statement here. Let's see whether that actually works. So first we're going to enter 2 gladiators. So give me names. Who are we going to pit against each other?
Alex and Steve.
That's funny. Alex, give me a number.
Alex and Dieter, yes. Let's do it.
For some reason, I don't know why, Steve. Vicky just went over your head and gave this to Dieter. So how many lives does Alex have?
1.
Okay, how many attack? What's my attack value?
5.
Okay, defense value?
2.
Okay, so now we have Dieter. So give me numbers for Dieter.
Okay, let's say Dieter has like 5 lives.
Okay, attack.
Let's make it a fair fight, okay?
Sure.
Life is never fair. Dieter will say his attack strength is like 3.
Okay, and defense?
2.
Okay, I'm a dead man, but let's go. Let's see how this works out. So Gladiator, Alex hit Gladiator Dieter for 1 point of damage, and it says that now you have 4 lives. And then you hit me for 1 damage, and I have 0 lives, and Gladiator Dieter is the winner. So that was a quick one. But that, I know it's a bad idea to bring knives to gunfight, so I think that's what I did, and I lost. So, but it looks like this is working. Let me try to make this. Let's try something different with just a bit more in terms of lives, so we have more of a process here. So let's have, I don't know, Um, let's have Bill Gates. I can't do it like this. I need to do it with an underscore. So Bill Gates is going to be like with 5 lives, with strength, I don't know, 8, and defense 12. And
Elon Musk.
Okay, well, there we go. Yeah, let's not touch Steve Jobs. So let's take Elon Musk. So Elon Musk, okay, he's gonna have 4 lives. He's gonna be a bit nastier, but he's going to be slower. So let's do it 8. Let's swap this thing. So Gladiator Elon Musk hit Gladiator Bill Gates for 1 point of damage. So he's down to 4. Bill Gates misses. Miss. Well, they're gonna miss a lot. Okay, Bill Gates hits in return, 1 more point of damage. So we have miss. Oh, that's quite a fight. Okay, another one. Okay, Bill Gates is down to 1 life. So, there we go. Bill Gates is down. Elon Musk finished him off. So we have Gladiator. Elon Musk is the winner. So that's the Gladiator problem. I know I saw some messages, so let me quickly look through.
They're all commentaries. They're not questions.
I think hold on. So okay, this is yeah. Lives, hit points, yes. Don't we have the option when the other attacks and we protect, and the other way around? So each time someone attacks, he is the self, so he is the attacker, and the other is always the defender, because that's the way that perform attack works. So whatever class or whatever object is performing the attack, that object is the attacker. So there is no, I mean, we could have done a separate, which would be called defend, and then call that method and get back the result. But in this case, I thought that was a bit too much. So no reason yet to do that. Steve, I see your hand.
I'm just repeating a question from Tony. Why are there asterisks on line 13? Why are there asterisks in front of the get stats method?
Oh, okay, yeah. So I didn't get into the explanation of this because I just had it pre-written, but it's a good question, so let me answer that. The way this works is if you look at the get stats function, what it returns is a tuple. So really it returns this. It returns a tuple of 4 values. And here, when we call Gladiator, we actually need to provide 4 parameters. We cannot simply send in the result of this call, because this is going to be 1 parameter. It will be a tuple which contains 4 values. That's 1 parameter. So in order to unpack this tuple, you can put an asterisk in front of the name, and the asterisk is the operator which unpacks the values or the elements of a sequence into these values 1 by 1, separated by commas. So basically, when I'm putting an asterisk here, I say take the tuple, unpack it into 4 specific values, and only then send those 4 specific values into the constructor for the Gladiator. Because
okay, so if you didn't have the asterisk, what would it look like?
If I didn't have the asterisk, I would get an error.
You would get an error, okay.
Because I would try to pass the entirety of those 4 parameters into the name parameter, and it would say that I'm trying to pass 1 when the class is expecting 4. So another way I could have done this, I could have saved the result of this call into 4 variables and then write 4 variables here. But it would look a lot messier. I mean, I'd have a ton of variables that I don't really need, because they're used and discarded immediately. I hope that answers the question.
So, Alex, when you're using these asterisks, okay, it's all by position, right? I mean,
the same sequence, yes.
Right. Basically, the first asterisk will take the first one, the second one will take the second one, right?
Yeah.
And then if you have like something you're unpacking, like a tuple, if there's like four elements, and then you only use say two of them, that's okay, right? I mean,
Not in this specific situation because the class expects four parameters. So if you pass in any other number, you would get an error saying that it's incorrect number of parameters.
no,
So
but
that's
but what I'm saying is like in line 13, over there, it would just take the first two, right?
you mean because of this.
Yeah.
Why two? No, this is two because I have two initializers here, comma separated. So it's basically it's the same as if I have written current player equals gladiator get stats. Sorry, and then other player. So it's the same thing. I'm just doing it on one line instead of two lines. So this is the same thing.
So, so I'm a little bit confused. When you're unpacking the tuple, right? Like, what are the elements actually in your tuple?
So this is the tuple in line 32.
Okay, okay, and so current player takes name, right? And then gladiator asterisk gets
Current player takes the entire object. Current player is an object, a gladiator object, and other player is also a gladiator object. So that's what's returned by this call to the class constructor, or initializer, to be more correct.
okay, and then but when you have that asterisk get stats, right? Which element is it taking from that tuple? Lives, right?
Which it's taking all of them. So instead of this, you get basically this. So these four these four parameters are passed into the gladiator function. It does this, and then gives you back the object,
Oh, I see.
the gladiator, the specific gladiator object, which is saved here.
Okay. And that other player is another gladiator object with
Yes.
right. Okay.
Yes. So that's why we enter data twice, because this function is called twice. It's called first for the first one, and then second time for the second one.
All right. Thank you.
Okay, no problem. So I hope this is clear. Yes. So is there any difference in code's efficiency and weight having current and other player on the same line? No, there is no in terms of efficiency. It has nothing to do with efficiency. It's just basically having less lines of code, just for visually. I tried to make main, as small as possible to actually show that the main function is quite small. You don't need a large main function for this simulation, because most of the things are happening in the class, in the object itself. Okay, cool. So if there are no other questions on this assignment, I propose we go into today's topic. Save this. There we go. And let me share the presentation again. Here we are. So yeah, let's talk about the first thing that we wanted to discuss today, and that is decorators. So first, as usual, let's talk about what decorators are. Let's give a definition to what a decorator is. And decorators in Python are functions, so this is important, they're usually functions that modify, or in other words, you could say decorate, that's why they're called decorators. They decorate the behavior of other functions without actually having to change the original code of those functions. So you take an existing function, it could be any function, ideally, and you use a decorator, which is another function, which modifies the behavior of the first function that you took. So if you need something additional to the behavior of that function, you do not have to rewrite that function. You do not have to change the code. You can add something on top using a decorator. And while I still understand that this sounds like, gibberish examples, that's why we will look at this as examples. So first, let's take two very simple regular functions like we already know. For instance, the first one is going to be the add function, which takes in two parameters, adds them together and returns the sum. So a very simple, function. The second one, let's say, is a square function, which takes the one parameter and returns the square of that parameter, not the square of the square, that parameter to the power of 2. So for instance, if we say add 1342, the sum of that would be 55. If we take the square, if we do the square of 12, we get 144. This is not the square, right? The square means the inverse.
No, I mean, that's a square because you're taking 12 multiplied by 12.
So there is a difference between square and square root sums.
Root, right. Square root of 100 would be like 10.
Yeah, but the square of 12 is
Yeah.
144. That's normal. Okay.
Yeah.
Because at this point, I'm like, no, is this correct? Okay. So now we're going to look at how we can take those two different functions. They're different. They have different number of parameters, and decorate them for a certain reason. So in this case, I know Nick, for instance, proposed to use a decorator to measure the amount of time it takes for a function to perform its job. And that's actually one of the ways you could use decorators. You want to know how fast your function is. In my case, I would propose to use a decorator to actually use it as a debugging tool to see what's going on inside the function that we're decorating. So I'm gonna call it logger not in the sense that we're cutting wood, but in the sense that we are trying to log what's going on. And the important part here is that our function will take another function as a parameter. And this is something we haven't done before, but functions, much like other things in Python, are also values. So you can actually pass a function as a value. Now, we actually have done this. If you remember sorting, and if you remember the key parameter of sorting, we would sometimes pass functions into the sort function in order to tell it how to sort a sequence using by length, for instance. We would then pass in the length function, etc., etc. So here the idea is the same. We take the name of a function, the function that we want to decorate, and pass it in as a parameter. So now the next thing, inside this function that we are defining, we are going to define another function. And this we haven't done before, but this is completely legal. So you can do a definition of a function inside the definition of another function. And this function will only be available inside this definition. And this function, we're going to call it wrapper because we're actually going to wrap this function around the original, sort of do the decoration. So it's usually called a wrapper by default. You can call it whatever you want, obviously, but it's often called wrapper. And we're going to have this syntax. We've just discussed asterisks. What do asterisks do? Asterisks actually allow you this syntax asterisk args. Well, once again, this is convention. You can call this whatever you want, but args is short for arguments. And it means that you can pass in any number of arguments. So we do not have to know in advance how many parameters the function actually takes. Because remember, like the add function takes 2 parameters, the square function takes 1 parameter. We do not know this in advance, but we can still get all of them using this syntax, and we will get a tuple of arguments. And the number of arguments can be from 0 to infinity. So now inside this wrapper function, we're going to do all the decorating. So for instance, I would like, before we run the function, I would like to print out its parameters. I want to see what is actually passed into this function. So I'm going to write just parameters colon and the arguments. I want to see the arguments. So this is the decoration. This is something which will be done outside the original function. Then I will call the original function. So here I'm calling func, which is the function which is being passed in, with the arguments which are given in the wrapper function. So I'm basically calling the original function, and I'm saving the result of that original function in a variable. I just want to call it result. And the reason I'm doing this is because after the function has run its course, I want to do another decoration. I want to return the return value. I want to see, to print out what the return value is. So you can understand that this will allow me to find errors. For instance, if for some reason I'm passing the wrong argument into a function, or I'm getting an incorrect return value, I will be able to see this using my wrapper. And only after I do these 2 decorations, I will actually return the result of the original function. So basically, lines 1 and 3 are the decorations. Lines 2 and 4 are just using the original function. So I'm adding something before the function call and after the function call, because I need this for my debugging.
So, Alex, which ones are lines 1 and 3?
I mean the 4 lines which are inside wrapper. The first and the third one, they are marked decoration, so that's the decoration.
Okay.
And the second and the fourth one are basically using the original function. So if we remove lines 1 and 3, we'll just be calling the function and returning the result. So nothing would have changed. So it's line 1 and 3 that are actually changing or decorating the behavior. And then the last thing we need to do, we actually need to return the wrapper from this function, because the logger function has to return something, and the thing that we're returning is the definition we've just created. So we're saying, here is the new function that you asked for, and you will get this behavior. So let's take a look at how this actually works, how this would actually work.
There's actually a question in the chat.
Okay, let me take a look. So Demetrius, you're saying you thought decorators were something like property, and they are. We will get to that, but you need first to understand like what a decorator is, and then use it rather than the way around. So yeah, at the moment I'm showing how to actually write a decorator, while property is already a decorator that's been created by the Python team, and you just use it. So let's take a look at what happens if we actually call the logger function which we just created. So let's say that we take our add function. Remember, we have a very simple add function. Takes in 2 parameters, adds them together, returns them back. So let's say now we're saying, okay, let's modify this. Let's decorate it. So let's take the logger function we just written, pass add as the parameter, and save it back into add when it gives us back the result. We could have called this, like decorated add, but I'm just using the same name for simplicity. So we pass add in, it modifies this add function in the wrapper, and then it actually returns the wrapper. So what we're getting back is this function we've just defined here. So instead of this, we're going to get wrapper. So add would equal the wrapper that is returned. And this means that when we are writing add 13, comma 42, we're actually now printing out the wrapper 1342. So instead of add at that name, we actually have a wrapper which is returned here. And when we do this, we will get initial line with the parameters. So we'll get parameters and then the tuple with the two parameters. So this is what this does, the first line. This is of the decoration. After this is printed, we will get all of the calculations. After the calculations are done, the second decoration happens. So we print out the return value, and only then the result 55 is passed back here, and we are printing it here. And so here we simply print the result of the function 55. So this is happening inside the wrapper, the first and the second line of output. The third one is just printing the whatever is returned. Does this make sense? Or because I would answer questions right now on this, because I know it's not an easy topic to take in, immediately.
Why would you want to use this?
Why I would want to use a decorator?
Yeah, I still don't quite understand, like, why would you want to do this? It seems kind of extraneous.
Okay, so imagine that I'm writing a function which is a lot more complex than adding two numbers. And for some reason, I have bugs in my function. It's not working correctly. I wrote, 30 lines of code. My function is doing something, but it's not doing what I want it to do. I want to debug it. I want to understand what the problem is. And there are two ways I could have done this. I could put print statement inside my function, the one that I'm debugging, and spend time, trying to figure out what's wrong. Or I could create a decorator which would do the same, but it would do this for function that I do. So let's say I wrote 10 functions. All 10 of them, need debugging. I do not need to place print statements in every one of them, what the parameters are passed in and what the return value is. I just need to decorate it with this single function, and this allows me to save time and code in doing this. So this is one of the examples of how decorators could be used, the one I'm specifically looking at here. Does that answer your question?
No.
Alex, for the very first line you have there, you have add equals logger add. Does that first add have to be the same name as the function?
No. So
Okay.
like I said, instead of the first add, I could have done something like decorated add or updated add or whatever. It's just a variable name. The reason I'm using the same is that I wouldn't need the old function anymore. So that's why I stick it in the same name. But it can be anything. You will then keep both the old function and the new function, the decorated version and the undecorated version.
Okay. Huh.
Anything else? Okay, in which category can we put decorators? Inheritance, because it takes the function as the parameter, or polymorphism. Decorators have nothing to do with object-oriented programming. That's what I said at the beginning. Decorators are not OOP, so it's there is no sense trying to fit it to something which has to do with OOP. It's neither inheritance or polymorphism. It's just a function which takes another function as a parameter and updates it.
There's a couple questions in the chat too.
I was answering a question in the chat. Which ones did I miss?
Oh, in which category can we put decorators?
I just answered that one.
Okay.
So any other questions before we move on, because we're going to be building on what I've just explained. So probably to, okay, no more questions. All right. Well, as usual, if something pops up, please do let me know. So now we come to this syntax with the @ sign, because instead of doing this, instead of writing add equals logger add, Python has a simpler syntax which does exactly the same thing, and that is before your function you need to place this line. You started with @ and then you write the name of the decorator that you want to use. So this line basically is the same as this line. And it's simpler. So you don't have to write this somewhere in your main code. You just add this header before the function, and it does exactly the same thing. Okay, I'll have to experiment with this because I use a lot of print statements when debugging. So yeah, this, and I don't know how much time we'll have remaining today, but maybe we'll actually get to use this in a specific program. So this would be the syntax that we would be using. For instance, with add, we would use this, and then we have another function, and I would place this before the other function as well. And now I can use the logger both for add and square. So for instance, with square, now, if I do print square 12, what would be the first line that I would get?
It was the arguments line, right?
Exactly, the parameters. First, I would get parameters. Since it's a tuple, it has to have the comma at the end, but it would give me the parameters, which is only 1, 12. Then the value would be calculated, so this line would be done. The function is called. We get return x multiplied, brought to the power of 2. Return value 144 is printed because it's saved in result and printed here. And then the actual print on this line is executed. For instance, we could have called this function without the print. We could have just written square 12. And in this case, the last line would not have been there. We would have just got the two wrapper prints, and that's it. But in our case, we are actually printing out the result. Regarding @logger, is that the exact word Python uses? It's not the exact word Python uses, it's the name of the function that we defined here. So you can call your decorator whatever you want. And then after the @ you have to write the name of the decorator you're using, and then it's applied to the function. You can have several different decorators with several different tasks. You use several decorators on one function. So if you have several decorators that do the same thing, like the one that Nick proposed, measure time, how much time a function takes to work, we could have also placed timer here. We would have had @logger, @timer, and they would have been performed in that sequence. So first the logger, then the timer.
Alex, is a decorator just kind of like it kind of prints something about the function? I can't really think of anything else that a decorator would do without actually altering the function.
I think I missed a bit of one of the sentences.
Well, you can change what it's returning, Vicky.
Right. But right. I mean, you would print something about the function. It can you can change what it's returning, but the function itself like remains intact, right?
Yes, that's the point.
Which means like you could take out whatever your decorator is, and then your function would still do exactly the same. And so the decorator is either to provide more information to the user about your function, or it's to help you debug, basically.
Well, I mean, you can use decorator to change the function without changing the code of the function. So for instance, you can take a built-in function, like let's say you have, I don't know,
Map.
len function.
Okay.
you can actually change the behavior of the len function. For instance, as I didn't hear who proposed the idea, but for instance, you could twice the length of anything that you're measuring, simply by saying return length, return result multiplied by 2. The question is, why would you want to do that? That's sort of a strange, but maybe in some instance, you need to return twice the length. And you're doing it without changing the code of the len function, because you don't even have access to the code of the len function. It's written in C by the Python team. But you can modify its behavior like this. And I agree with you that decorators are very specific in terms of use cases. That's why I was a bit on the fence when you said I want to learn decorators. And I'm like, you won't need them. You won't use them. But you wanted to, so here I am. Does that answer your question?
Yeah. Just to add, most of you won't be writing decorators. The main reason that I went through it and Alex is going through it is just so you understand how they work. But mostly you'll be using decorators that other people have written.
Right. And we'll actually get to that when we talk about getters and setters, because those are things that use decorators. And if you don't explain decorators before, but you start using them, like Nick said in his videos, it feels like magic. You sort of go, I have no idea what's going on. I just put this strange at something in front of a function, and now it works differently. So now at least you understand what's happening behind the scenes in order to give you this or that result.
Also, is decorator a type of property?
No. Once again, decorators have nothing to do with OOP. Properties are OOP. Decorators have nothing to do with OOP. They are used in OOP, but they are not OOP by themselves. And so if there aren't any other questions or comments on decorators, we can actually go into getters and setters, which are, more useful. So this is actually something that we're going to use in object-oriented programming, at least if we want to be Pythonic about it, and not directly access the attributes objects, which is considered not very good practice unless you know exactly what you're doing. So let's take a look at an example class. And I'm going to call this class example. And in this class, in the initializer, we're just going to get a number, and we'll save this number as an attribute. It doesn't matter what it means. It's just an example with a number. So now when we call the initializer for this class, capitalized example, and we pass 13, for instance, as the parameter, we have created an object of the example class. So now we have a specific object, which is also called example lowercase. And now we can do things with this object. So for instance, we could say, please print the number attribute of this example. So if we use the dot notation, example.number, we will be getting the value of the number attribute. So in this case, 13 will be printed out. Also, we can change the value of that number attribute, or set the value of that number attribute using this syntax. Example.number equals 42. And this will change the value. And if we print it again after this, it will be 42 and not 13. So the reason why I'm using, the verbs getting and setting here is because this is going to be about getters and setters, because in real life, this is discouraged. So when you try to directly access an attribute from, or heaven forbid, you're trying to modify the attribute from outside, this opens a can of worms, like why you shouldn't be doing it, especially in a very large program where this could lead to a number of mistakes. And this I forgot the word. This sort of breaks the encapsulation principle that we're going to talk about right now, because in object-oriented programming, there is a design principle which is called encapsulation, which states that the data stored in an object shouldn't be accessed directly. Rather, it should be managed by the object itself, meaning that there should be methods which work with the data of that object internally and then just give you back a result. So you don't access attributes directly, you do it through special methods which allow you some additional functionality to make your life a bit easier. So there will be three phrases which sound very, blah, blah, why you do it. So it protects data integrity. That's what I was talking about. It hides implementation details. So this means that like an object or a class is a black box and you do not need to know what's inside in order to work with it. And it actually allows you to change things when you're coding inside the class without breaking code that's been written outside. This is not that important, but this is just to show that there are actual reasons for this, so it's not just whimsy. And Python, as opposed to many other languages, Python does not restrict you in accessing data directly or changing data directly. It simply discourages via using getters, setters, and properties, and that's something that we're going to talk about right now. But in this sense, Python is a lot more open as opposed to languages like C++ or Java, private or public attributes, and if it's a private attribute, you will not be able to access it without using a getter or a setter, or otherwise you would get an error. In Python, you will not get an error, but Python says, don't do this unless you really know what you're doing. So what are getters and setters? Getters are methods that actually define an attribute's reading behavior or getting behavior. So when you try to read or get the value of an attribute, getters define that behavior, what actually happens when you try to do that. And setters are the opposite, methods that define what happens when you try to assign or set an attribute's value. That behavior can also be changed. So by default, that behavior is if you get a value, you just get the value. If you set a value, you just set the value. Nothing else happens. So you get what you get or you set what you set. But you can actually change that, make additional things to this. And you are already probably thinking, aha, decorators, because decorators allow you to do additional things. And that's exactly what I'm looking at. So let's go back to code. Let's say we have a class which is called balance. And when I say balance, I mean account balance, like in a bank. You have balance, which is initiated with a single parameter, which is cents. The reason I'm using cents instead of dollars, because I do not want to use floating point dollar values, because floating point numbers, if you remember, are very imprecise. You can get some mistakes with floating points that actually incorrectly show you the final result. So I'm going to store anything in cents. So for instance, if I want to store $100, I'm going to store 10,000 cents instead. So the first thing I'm going to do if I want to, go the Pythonic way and use encapsulation, note that when I'm naming the attribute itself, I will put an underscore in front of the name of this attribute. So I'm not going to go self.cents, I'm going to do self_cents. And the reason I'm doing this is because by convention, so this is not enforced, this is for the programmer to see by convention, that if you see this underscore in front of an attribute, it sort of means that this is a private attribute. Please do not try to access it directly. Once again, this is not enforced. If you want to access it directly, you will be able to. This is sort of a warning. If you see an attribute with an underscore in front, you should know that, don't access it directly, use getters and setters instead. So now I want to create a getter method. So remember that getters and setters are methods. The first one I'm going to call get balance. Well, that's why they're called getters. They get you the value. And it will be a very simple method for now. But I will add some functionality to it. So I will do this method in a way that though I'm storing cents, it will actually return dollars and cents to the calling program because, no one shows you your balance in cents. I'm going to store it in cents, but whenever someone wants to get the value, I would actually provide a tuple, and I placed the parentheses, to make certain you understand that this is a tuple of two values. The first one is going to be the amount of dollars because this is integer division. For instance, if I had, 123 cents, integer division by 100 will give me 1, so that's $1, and the modulo of 100 will give me 23, so that would be 23 cents, so I will get 1, comma 23 as the result. And this is an example of how a getter changes the functionality of, basically getting a value. It actually returns something else. The same could be said for setting. Using a setter method, it will now take a new value, so that's what I want to set it to. And I, for instance, can check for errors because a balance, let's say we do not work with negative balances. And in case the balance is negative, I will actually raise a value, so raise an error. So this will actually break the program. I will raise a value error and it will say balance cannot be negative. So I'm actually checking for unaccepted behavior, for invalid behavior. If you're trying to set my balance to a negative number, you're doing something wrong that should not be happening in my program. Otherwise, if the value is not raised, then I simply set my cents to the new value. So these are examples of getter methods and setter methods as they are used in many programming languages, which actually do not have decorators. So this can be used in Python. There's nothing restricting you from using it like this. But in Python, it's done a bit differently using decorators, and I will show you this on the next slides. But first I will answer a question, obviously. Vicky, shoot.
Okay, so you said for your getter, okay, you actually changed the the value, but I don't see how the getter changes the value. I think with the setter, you changed the value. Or did I hear you incorrectly?
I'm saying that I'm providing a different value from what is stored inside the object. So inside the object, I'm storing cents. For instance, I'm storing 123 cents. And if I access this attribute directly using the dot notation, so saying like balance dot cents, I would get 123. But I can create a get balance method, which would be a getter method that would actually return a different value, which is more useful to whoever is calling and working with this object. Because no one on the outside would be interested in cents. They would be interested in dollars and cents, and that's what it does.
Right. But the variable sense still has the original value.
Yes.
Right?
Yes, exactly.
Okay.
That's
Okay.
true.
Okay.
That's absolutely true.
Okay. And then I just have like one comment. I don't know if this is helpful. Nick told me this, and then I thought this was like very illuminating because I don't really understand why you would want to ever use like getters and setters when you can access those variable directly. Um, and then what Nick actually told me is that in the setter, just as you wrote, okay, you could have if statements. Whereas if you don't have getters and setters, right, even though you could access them directly, if you want to change them, you would need to actually go back to the original constructor, which is the init method, and then change it there. So that's actually one reason. I don't think that's the only reason why setters could be helpful. He actually told me a couple other reasons, which I can't really remember right now.
Okay, but maybe actually, Nick, you can jump in because I remember you talking about it in the videos. Do you want to talk through it?
Yeah, Vicky is referring to, she also asked about it in office hours, so I think she's referring to that.
Okay.
I don't remember everything I said there, but what I was saying about the setters is exactly like you have in this example, Alex. It lets you add extra logic. You can do validation checks,
Yeah.
things like that. So it gives you a lot more flexibility and control than just letting people access your instance variables directly.
Yeah. Exactly. So basically, validation is one of the main reasons why you would have a setter method and check that the values are actually valid. So for instance, let's say someone tried to set the balance with a string, and that's a no-no. You can't have a balance with a string, so you can actually check the type that's being given to you and raise a type error if it's different from a integer. Or for instance, if someone tries to give you a floating point number, it's a number, sure, but cents cannot be floating point numbers. You can't have 1.5 cent. So in this situation, you would also raise an error and says, I only, accept integers and nothing else. Okay, so now let's take a look at an example of this class in action. So 1, 2, 3, I guess, was in my mind. So we create a object which is called lowercase balance, which has the initial balance of 123 cents. And now when we print balance and we use this method, we actually get this as a result. So we don't get 123, we have a tuple of two values. The first is the dollar tuple, the first is the dollar value, the second one is the cent value. If we want to set it to a different value, for instance, if we do 99, that is a valid value. So after this, we'll have 99 cents instead of 123. If we get the balance, we now will get $0.99. But if we try to set the balance to something different, for instance, a negative value, then in this case, we will get a value error because we programmed that value error here. And it will raise this error if we try to do this with a negative value. So that's the way it would work with the way we programmed our class for now. So does this make sense? Are there any questions on this slide? Because next I'm going to talk about properties, and we'll finally get to decorators, how decorators are used with getters and setters. No questions from Nancy? Okay, so let's talk about properties. Finally, what are properties? Simple definition that properties are attributes with additional functionality. So this is basically what we've been doing with getters and setters, but the difference is that getters and setters are actually methods. While properties are still like attributes, but they do have this additional functionality which a regular attribute does not have. And that's the main difference, attributes versus methods. And properties use decorators to allow you more natural access syntax and without the dangers of actual direct attribute access. And once again, if this sounds like gibberish, let's take a look at the specifics. The beginning is the same. So we have class balance, cents, we have the private attribute here, but now we are going to use a special decorator, which is called property. And property is the decorator which actually turns a regular attribute into a property. So now we know we will create a getter which will be called balance. So this creates an attribute. From the outside, it looks like an attribute which is called balance, which will do the same thing it did before. But now we will access this attribute the same way we tried accessing them before, simply using the dot notation. And I will show you this to you in a moment. And another decorator that we can use is a setter decorator, and this is the way it looks. So this decorator is for getters. It's always going to be at property. Now, this is something which, this is a specific name which you can use, you have to use. So this is not something that you created, this is something that the Python people created. They called this decorator property, so we cannot call it logger or blah blah or whatever, you have to call it property. The second one is has this syntax. You have to take the name of the attribute, which is the property, so they have to be defined in this order. Then use dot, and this is another decorator which allows you to define the setter. And now, if you will see that actually the definition has the same name. It's in both cases, here it's balance, here it's also balance. The difference is that for the getter we only have self, for the setter we have self and the new value to which we want to set the attribute. And once again, inside the validation is the same. So this part does not change at all. The difference is the use of the decorator, and that now I have a different name for the attribute, because it's logical for the outside world to talk about balance and not sense, because for the outside world, sense do not make sense. Sense, I'm sorry, sense and sense sounds very similar. So sense make sense only inside the class. I do not tell them to the outside world, so I'm going to create balance. And now, for instance, I create another object with this amount of cents, which is basically $123.45. And now I can use this. I can use this syntax. Remember, this is the same syntax we used before to directly access an attribute. It looks like an attribute, but it's not. It's in fact a property, because property using this decorator. And now, instead of myMoney.getBalance parentheses, we can simply say myMoneyBalance, and it will give the same result. So trying to get access to the balance attribute, it's not an attribute, it's a property. Property has additional functionality, and we wrote the functionality here. So now we will get this attribute or property will give you this result. And the same if we try to set the balance. Now, instead of myMoney.setBalance, 1 in parentheses, we can use the old syntax. We say myMoney.balance equals 1. This is the same syntax we used before to directly change the value of an attribute. And we bad thing, but now we're actually not accessing the attribute directly. We're doing through the property, and we have validation in place. So in this case, everything will be okay. This is a positive value. So if I print it out, I will get $0.01. But if I try to set it to -20, in this case, I will get a value error, because we have that validation built into the specific property, which is balance, through the setter decorator that we used on it. So this is a very long way of showing how decorators are used in object-oriented programming to make getting and setting attribute values safe and Pythonic. And the reason why I went through this to actually, for you to have an understanding of, what comes from where. So it's not just magic. But basically, in the end, this is the only thing, let me get back here. This is the only thing that you really need to understand, right? When you are creating a class for each attribute that you want to be visible to the outside, you can turn it into a property using the property decorator. You will get the getter, and using the setter decorator, you will get a setter. And now through them, it's this basic syntax which we've used before, but now you get additional functionality that wasn't there before, though the syntax remains the same as previously. So let me look at questions. Is this how things in lambda mu, which isn't Python but is OOP, can do actions? I have no idea what lambda mu is. I wish I could answer that question, but I have no idea what that is. Can we not have setter if we do not have a getter, because the syntax is getter name setter? You cannot. Yes, you're correct. You cannot have a setter if you do not have a getter. So you need first to define your attribute as a property using the property decorator. And by default, that also creates the getter. And then you can also only do the setter using the getter name. So yes, you need to have both in order for this to work. Any other questions, comments? Because I think this is...
in the init, you are not having validation now. Could we use the decorator there to validate?
In the...
You have self.under-sense. Could we call the setter there to just say self.sense? So right now, if we create a new class object, and give it -5 cents, it would not create an error.
True, yes. That is true, because in order for get this error, we would actually need to get rid of the underscore. And then if we get rid of the underscore, we will run it through the setter. And this will validate. So this is a good point. Yeah, I was writing this. That's absolutely true. So at the initialization stage, if for some reason we decide to create a negative value, it will actually allow you to do this. But if we remove this underscore, even during initialization, it will immediately access the property and the setter will give you an error if the value is less than 0. So yeah, thanks for that comment. That's something that I missed.
Well, you would need to call it self.balance. Sorry, not
sorry. Yeah, right. It's not going to be sense. Correct. It has to be self.balance in this and wait. But if it's going to be balance, yeah, then it won't work. That's true. In this, because I'm using a different name for the property. That's correct, because I'm not using sense here. It would not work because self-balance would actually try to save it into safe sense. Yeah, I don't think that would work. Definitely not. If we just remove the underscore, it will tell you that there is no such method because we only have balance methods. I think you can have setter if you don't have a getter, but not 100% sure. I might be wrong, but I don't know how you can have a setter in the sense using decorators. Obviously, you can have a setter without a getter if you're just using functions, but I don't think you can have a setter without a getter if you're using properties. Nick, maybe you can chime in here.
Yeah, I think you're correct because
Okay.
at property actually defines the property, and then the setter is actually something you add on top of the property. So you
Yeah.
need to define the property first, which also gives you a getter.
Right, right. Because really in Python there is a getter, so you can have balance.getter, but it's almost useless. There is actually no need to use it because property already gives you a getter. And Vicky, you're saying I don't think you can add the initializer. You mean you can actually? There is nothing stopping you from adding conditions in the initializer
Well,
like this.
because my understanding from Nick's office hour is that what makes um setters useful is that you can put conditionals into the setter.
Sure.
Um, and then I thought I had asked Nick, like, well, why don't you just put the conditionals in your initializer constructor? And then I thought he said you can't do that.
You can do that because an init is also just a method. But the
Well,
way I did it in my video is I reused the setter so that I didn't have to duplicate the validation logic in two places.
Exactly.
well, I mean, if you could put the conditionals in the initializer, I, um, I think that makes the setter a lot less useful, no?
No, because the initializer is only called once when you create the object. So when you create the balance object,
Oh, right,
it'll
right.
call the initializer.
But then everything else goes through the getters and the setters. Yeah.
Setters.
Yeah.
And then every time you create, I guess like you could keep on using the setter and the getter, right?
Yeah.
Yeah, you
Getters and
use them.
setters are for working with an existing object. The
Mhm.
init is only called once to create the object.
Right. But every time you create a new object, you call init again.
Yes.
Yeah.
Yes.
Okay. So I do have a question, Alex, regarding your property here.
Yeah.
You have defined balance um, under both the getter and the setter.
Yes.
Is that gonna be problematic?
It's not going to be problematic. It's the way it has to be done if you're doing it using these decorators. So Python has to see the same name because basically you're first saying that balance is the property, and then you have to say that you are doing a setter for that specific property, and it has to be the same name. The difference in syntax is that here you only have self, and here you have self, and then the parameters which are necessary, which
So
you
I guess in other
that you
words, if
need to
you were
set.
to change balance in either the setter or the getter to something else, this wouldn't work.
This would break the code. Yes.
Yeah, I think it would actually work, but it's just going to look weird because you would get it using one name and you would set
Yeah.
it using a different name. So it's not going to look like one property. It's going to look like two different things. I have
Okay.
not
So
tried it,
basically,
but I think it would work.
so you think if you do add balance dot setter, but call it here something like, I don't know, set
Balance one.
balance or balance one, you would need to access or setting through balance one. So they would look like two different attributes.
Yeah, I've never tried it, but I think that's how it would work.
Okay, that could be the case. The reason I'm not sure because I haven't tried it as well. So
Yeah,
this
it's a
is
weird thing to do, so
yeah,
no one should
yeah,
try, no one
but
should do that.
I don't understand why you shouldn't do that. I mean, because to me this looks more confusing, but that's could just be me. So
okay, but let's look at a very simple example with a simple variable. Let's say you write a program that you have variable name, right? And would it be weird for you if you want to use that variable, you would have to use name in the code, but if you want to set a new value to that variable, you'd have to use name one. that's weird because that looks like two different variables.
Yeah. Okay.
So that's the reason. Okay, so anything else? Any other questions, comments? Because that's the last slide that I have here. We have about 20 minutes remaining. I would actually try to put this, into a program, to write a simple program. Don't know how much we'll be able to, write in 20 minutes, but let's give it a go. A second to open VS Code.
While you're opening the code, can I just ask Dieter and Nick if they want to say anything to the group since it's our last session?
You really put us on the spot.
Sure.
It's
Well,
your
I
Oscar
really,
well, I mean, you don't have to, Nick, but I figured this is your Oscar moment. Doesn't come around every day.
I can go first. So Nick has a template. I really enjoyed working with all of you. It's been fun to see the curiosity in the community and the engagement. It's been really fun. Also, some people getting up at whatever, 2 or 4 a.m. to attend these lectures. That's been inspiring to me to see people that dedicated. Thank you.
You're so gracious. You're always a class act, Dieter.
That you are.
Good template, but I can't follow that up, so I will just echo it. I haven't been able to attend a lot of the lectures because of the time, but I have been following along and watching the videos. And thanks, Vicky, for organizing it. I know you have asked for a lot of, you've asked for people to thank Dieter, Emma, and Alex, but I think you also deserve thanks because you're the one who really initiated the whole thing. And yeah, I've enjoyed working with everyone, and thanks for letting me participate.
Oh, well, thanks for participating. I mean, we let everybody participate. So, unlike like some Discord server people, but we're not like exclusive that way. And so thanks for being here, Nick. I learned a lot from you.
I will save my last words to the last moment. So thank you, Dieter. Thank you, Nick. I was looking through the chat in parallel, and I see, Momina, you're asking no destructors in Python. There are actually they're not called destructors. I believe they're called deleters in Python. So that's the third. Jesus, the third decorator you could use to define behavior when an object is deleted. But I thought that would be a bit too much for this lecture, since like deleting objects is a very specific thing. And as opposed in C++, where you actually control when the object is deleted, in Python it happens, whenever garbage is collected. And so you would have some weird behavior at times which you cannot predict. So I decided not to talk about leaders. Okay, so let's try doing something, in the 15 minutes that we have remaining, because I have some code here that I wrote, which is a main. So basically, I am creating 3 bank accounts here with some initial values in cents. Like this is $300, this is $50. For some of you who may be into board games, these are actually board game designers. Some of the most popular board game designers, I took them because I'm a board game fan. And basically here's a very simple loop where you select an account number, you select one of 5 actions here, so you can view the balance, you can deposit something, you can withdraw something, or you can transfer from one account to another, or just quit. And then if it's one of these actions is selected, you have one of 5 options happening. If you have not seen the match case syntax before, this is very simple. It's another way of doing an if-else, which reads more succinctly. So you're saying, I'm looking at the action variable, and depending on what that variable is, I perform, I either print the account or use the deposit method or the withdraw method or the transfer method, or I just quit, break out of the loop. So this I've written in advance. So now, as you can see, we actually need to write the bank account class. And this one is empty for now, so we're going to do class bank account. The initializer will be very simple. I'm going to say that it takes a balance, or let's call it cents, the way we called it previously. And initially, we're going to do self. I'm thinking which. Okay, let's go with self cents equals cents for now, and I will set a default here. I will say that if this parameter is not passed, then it will be 0. So for instance, here I have Bruno Faiduti without anything. This will actually be a 0 if this parameter. Oh, I need the name as well, of course. Name and number of cents. So now, the first thing, for instance, we would want to print the balance. So if anyone asks for a balance, we just want to print the account. So we need to set up the dunder str method here. And in our case, let's do something simple. We would say self name, which I actually have to define as well. I need to do self dot name equals name. Colon, and then I will give the balance. And in our case, let's say it's going to be the $sign, then it's going to be self cents like this, and self cents like this. And this should give me the printed description of the account, the name of the person, and the dollar value for it. So it's not going to run yet because there are some. Let's actually do just empty templates for these. So I will have withdraw self total, and for now like this I will do deposit self total. Why isn't it? And I will do transfer self other, so I'm going to transfer it to a different account. Also total. So now it's going to be like this, but I missed something somewhere. For some reason it's not. Oh, okay. Okay, this should be good. Let me see. Account name selected, yeah. So if we're talking about decorators and properties and getters and setters, this would be the place to actually use them. So let's start with name. I would create a property which will be called name. So now this property will be accessed instead of the attribute directly. It will only have self here, and what it will do, the basic logic would be self dot underscore name equals name. Here I would need to do this underscore here as well. Sorry, this is the getter. It needs to return. It's to return self dot underscore name like this. And if I want to do a setter, I would need to do name, and this one will have self and whatever the value is, whatever the name is. And then I would say self underscore name equals name. But here, for instance, in the name setter, I can have basic validation. I would say if not name, so if I'm given an empty string, I would actually raise an error. I would raise a value error and say, sorry, sometimes I by accident press so that the program would run. In this case, I would say name cannot be an empty string. And then I would do the same for the sense. So let's say we do a property which is called, we could call this one, I'm thinking which way would be better. Let's actually stick to sense, let's not change that. So we have sense here, and since this is a getter, it would return self dot underscore sense, and then sense setter would be the value. And once again, here we're going to do validation. We're going to say if new value is less than 0. In this case, we will say raise an error. It's a value error as well. And say balance cannot be negative. Like this. Okay, and I think once we've done this, we shouldn't have any errors in the main. So let's try launching it and see how it works. So basically it says enter account number. I have 3 accounts, so let's say the first one. It says Antoine Bowser's account selected, and we can try and watch the balance. And it actually gives us the string that we set up here in the str dunder method. So this is what it returns. The only thing that jumps out is that actually it gives us only 1 trailing 0 instead of 2. The reason for that is obviously because when you have a remainder, a 0, it will never. So in order to get the extra 0, we could actually do the following. We could write use a ternary operator here and do something like 0 if self sense is less than 10, I think, and then else we would have this. So basically it will add a 0 if the value is less than 10, so that we have a leading 0, otherwise it will not do that. Let's try doing it again. So account number 1. Nope, still not working. I remember running into this. Why isn't it putting this? Self-sense.
Alex, you can use f-strings have formatting options. So I think if
Yeah,
you
I
do
know that they
.qf,
do, but here it will lead to a certain problem. Let me remove this and do the, you mean this?
yeah, I mean, I guess it's not a float, so
Yeah, that's the
that's what you're
problem.
talking about.
Yeah, it will give you an additional 0, which is not supposed to be there. So if we run this, in this case, it won't give you anything different. It will give you the same result because it's not a float. But I don't remember why this one doesn't work. So the amount of sense. It should be working, but I have no clue why it's not working here. So now in our case, if it's 0, 0 is less than 10. Should be printing this. No idea. Let me take a quick look at how I've done this, because I remember running into this and what was okay, I had an entire function written which actually does the same. I don't know why it's not working. Yeah. Okay.
Did you save? Sometimes we don't save.
No. I mean, in this case, I think it was saved for some reason. Well, let me try again. Oh, okay. Maybe you were right. It actually did work now. Ugh. Okay. My mistake. Missed it. Making me try again. So this one works. I see that we actually have only 4 minutes remaining until, the end of the hour. And it's obvious I'm not going to be able to write all of this logic. But I do have this written out. So I wrote this out when preparing for today. I just didn't expect the initial part to take that long. So I will share this with Vicky, and you can at least look at it and go through it. And I will maybe spend some time commenting it before sending, so you have some meaningful comments in the code so that you're able to read through it. Because, yeah, in 3 minutes, I'm not going to be able to do all of this, unfortunately. So I propose we stop here, and especially since this is the last time that we're actually meeting in Life After Code in Place 2025, and I'm certain that most of the things in the chat are not questions directed at me, probably, right? Okay, Nick, I see that you wrote that you can have different getter and setter names and they still work. Okay, so that's nice to know. So now we can tell people that would work, but please never do that.
Yep, exactly.
So thank you for trying it out and reporting on it. Okay, so yeah, this is like the time for final parting words, and they would probably come quite difficult to me because we've been together for such a long time that I'm always at the end sort of sorry for things to end. And I, of course, wanted to say first and foremost thank you to everyone who contributed to this thing becoming a reality. Obviously, I want to say thank you to Dieter and Nick and Emma, who is not here because, yay, she has a real job now. But nevertheless, she did a lot to help us out, so thank you a lot. And of course, Vicky is always being so, I'm behind the scenes, everyone else should get the thanks, but I'm so humble, etc., etc. But I will repeat what you guys said, that without Nikki, this would have never happened. This is happening for the second time, actually, thanks to Vicky, because we did this last time, and then she said, let's do it again, Alex. And I said, yes, Your Highness, of course, Your Highness. And so, Vicky, thank you from the bottom of my heart. This would have never happened without you, and I know that you'll, but it's you are doing the content and I'm just helping out, but you're not helping out. You're actually what
Well, I
holds
mean,
all of this together.
It's actually very self-serving for me. I did it again to try to learn OOP better. And then I'm actually thinking maybe you're like not teaching this topic well enough so that, I can't learn it. Okay. Um, but it's okay. I don't need you anymore. I'll just go to Dieter and Nick. Okay. Like,
There you
I
go.
mean, I
There you
still
go.
don't really understand OOP, but
Now you have so many options,
yes, so
so
I
many
have
people
so
that
many options.
you
So,
don't have to deal with me anymore.
well, and so like I don't have to like deal with, trying to con Belyakov into teaching a whole entire course again.
Right, right, right. Because it's a quite a difficult thing to con Belikov, right?
Very
Right.
hard.
Of
And
course.
see, I actually have like gray hair now. I didn't have like that many gray hair last year. So, like,
I'm contagious. Yeah.
I had like a lot more gray hair, and I'm actually thinking like maybe I should go dye my hair or something.
It's
That's
just showing your Python skills are improving. With every gray hair, you've
exactly.
gotten
Look at
another
my hair.
concept.
The sad thing, Martha, is like, I mean, I think I told you this, right? Like I took um code in place 3 times, and then it's not because I didn't learn it the first time. I just keep forgetting it. And so I mean, I'm just afraid I'm gonna like forget it.
Same
That's
here, really.
But that's what happens when you don't use what you learn. It applies to any type of learning, although to some more than others. Like with bike riding, once you learn to ride a bike, it's difficult to forget it because it's muscle memory. With programming, if you don't practice it, it will disappear from your memory. I mean, even if I, stop doing it for 6 months, I will have to refresh stuff in my memory, and I've been doing this for a long time. So that's the way it happens, unfortunately. And if you want to, to keep it fresh in your memory, you have to use it. Do some projects on your own, go to Code Wars and solve, assignments there, or go to Lead Code, solve assignments there, or what have you. There are different sites which give you the ability to do that. So yeah, like I'll repeat it one more time. Regardless of what Vicky says about it being self-serving, etc., she too humble to accept anything. So, but I'm still very thankful. And I also wanted to say thank you to everyone who stayed with us until the very end, because I remember the first time we were like online and we had like 100 something people, and we were like going, oh my god, what are we going to do with all these people? And then the second time it's 60, and the third time it's 40, and we're like, okay, people are filtering out. That's the norm. That's the norm. And here we have like a core of 20 hardcore people who come here every time, and I am very thankful to you, obviously, because if it weren't for you, we wouldn't be doing this. We would be doing something like our office hours when it's like Vicky and Dieter discussing things with one another, but it would not be life after Code in Place. So thanks a lot, everyone. And yeah, I think
Oh,
that's it.
Emma actually texted me and said, she wanted to say goodbye to the group and then thank Dieter, Alex, Nick for helping out. She had a lot of fun. And she wanted to say if anybody is ever in Northern California to stay in touch, and feel free to look us up. I think all of us are actually in Northern California within like a 10-mile radius of each other, except for Alex. So if you're ever in Northern California, you can look up like Dieter, Nick, me.
Everyone,
Yes.
trust me. If somehow I end up in Northern California, we're gonna have a party.
Okay. Well, you can train your flag football team to come to the LA Olympics, 2028.
Right, right.
Start working on the visa, right?
Mm-hmm.
Things could change a lot in 2028.
Of course, of course. All right. So before I start crying, I think yeah, I think we should end here. Um, I'm I'm certain that some of us will probably see each other again somewhere for some reason. I hope some of you actually consider doing a section here, and maybe we'll meet there. So fingers crossed. And yeah, reach out if
Are
you
you
have
coming
any
back next year,
questions.
Belyakov?
Could be, I don't know. It's too far away. I'll make that decision when I get there.
Okay. Well, hopefully some of you would consider signing up for section leading.
Yep. It's a way to pay it back, pay it
Give
forward.
back to the community,
For
exactly.
sure.
I'm gonna hardcore recruit every chance I get now. I'm not going in alone.
Yeah,
Excellent.
and the thing is, okay, if they like ask
I'll
you
get it.
to sign up